Hi, welcome to the channel Too Rational. I'm Pranay Sharma, and in this video we are going to study while loop in R programming. This is part of a series of videos where we are learning basics of R programming using RStudio. If you haven't checked out the previous videos, I'll encourage you to do so. I'll leave the link down below in the description for the playlist. Let's get started. In the previous video, we learned for loop. Now we are going to see while loop. In while loop, we start the loop and we get a test expression. If the test is false, we exit the loop. But if the test is true, we go and execute the statement and then loop back again and check this test again. If the test is still true, we'll go and execute, loop back again, and we will loop this till the test becomes false and we exit the loop. So the basic structure of a while loop. Here in this round brackets, we are going to have some test. So the loop will run the statement till the test is true. So the advantage of while loop is we can use it when we do not know how many times do we need to run the loop. Let me just take an example. So find first 20 integers that are divisible by 13 and greater than 1000. In this case, I know the starting value that it is 1000, but I don't know how many integers will I have to check to get 20 integers that are divisible by 13. So in such case, I will use while loop. We'll first define the vector where we are going to store the values, VEC. I'll write it as null because I want a blank vector. Then I'll start the while loop. Say while. Now, while should run till I don't have 20 values in this VEC. So I will count the values, length, VEC should be less than 20. This is the condition for which we'll run a statement. So the statement will have if I want to check whether it is divisible by 13. But what is divisible by 13? So I need a number here. I'll say n starting from 1000. So I'll say if n modulus 3 double equal to 0, sorry not 3, 13 double equal to 0, that means divisible by 13, then VEC must be equal to combination of the old VEC comma this new number n. This is our while loop. Now if I run this, you will find that I did run this, but I'm not getting an arrow here. If I'm not getting an arrow like this here, that just means that my codes are still running. If I get a plus sign, that just means my codes are incomplete and R is expecting something else from me. But when I do not get an arrow or a plus sign, that just means that my codes are still running. Because this loop is not ending, and that is why you can see here a stop sign. This is very important. If I do not stop this, this will run forever and it will ruin my computer. So I need to stop this code. Okay, so I will have this stop sign here. If I press stop, you can see now I get this arrow here. So that just means now I am ready to write new codes. Now what was the problem? See here, if n, that was 1000, divisible by 13, it checked, it was not divisible by 13, it went back, and then again n was still 1000, then again n was still 1000. Every time n was 1000. In for loop, we defined here a vector, and each time the variable was taking one value from that vector. But here this n is not changing. So I need a code or a statement that would change the value of n. I'll say n is equals to n plus 1. This is called as an iterative statement. I'm increasing n by 1 each time the loop is running. And this is one of the disadvantages of while loop, that it can run till infinity if we do not write our codes properly. Now here you can see I did not get a stop sign, I directly got a arrow, because each time it changed the value by 1, checked, and there was a time when I got vectors with 20 such values. I want to show you. Here we go. These are 20 values. You can count. This is the 15th value. The number given here is for the most recent value. So this is the 15th, this is 16th, 17th, 18th, 19th and 20. If you observed, I have written less than. I did not write less than equal to. I wanted exactly 20 values. I did not want equal less than 20 values. I did not write less than equal to. If I had written less than equal to and run this again, you will find that I have 21 values. You can see 15, 16, 17, 18, 19, 20 and 21. You can see here also in the global environment I have 21 values. That is because while loop will run till the length of this VC is less than equal to 20. That means as soon as I got 20 values, still this statement was true, and while loop would run till I get 21 values. So that is why we did not write equal to. We'll run this again, because I wanted only 20 values. We can talk about the advantages of while loop. The first advantage is that the loop is stopped when the test is false. Hence, a loop can be made without knowing the number of times it should run for. For loop, we already had to tell how many times the loop should run. Here, we don't know how many times the loop will run, because it will run till this condition is false. Second advantage, can have complex code that in turn govern the run of the loop. So here we had a simple code that was determining, rather this, we were storing the value in VEC, and that is why the number of values in VEC was increasing. But I may have some codes that are changing the value of length of this VEC, sometimes more, sometimes less, and that will govern the run of that loop, because this loop will run till the length of the VEC is less than 20. So if I feel like something is not right, I can change the value of VC inside this code itself. I can have another if statement. If I get a lot of values that are divisible by 5, I want to decrease the length of VC, something like this. That way, the while loop will run for more number of times. And we have a big disadvantage with while loop, that it can create an infinite loop if we do not write the codes properly. Let's take a question where we are going to use both while loop as well as for loop. The question is, find the first 25 prime numbers. Assume that prime 2 is given to us. So we'll start with this. Prime is equals to a vector with the value 2. We'll start with this. So at the beginning, I don't know how many values to check. I know that first number is going to be 3, but I don't know how many values I will need. So I will be using while loop. It's a while length prime is less than 25 because I want only 25 prime numbers. I have to devise a plan how to check the prime numbers. If a number is divisible by any other number than just 1, I would say it is not a prime number. So let's say the number is 30. Okay, if the number is 30, I would check whether it is divisible by 2. 30 is divisible by 2, so I'll say it's not a prime number. And let's say 31. 31 is not divisible by 2, then I'll check divisible by 3. It is not divisible by 3, I'll check whether it is divisible by 4. It's not divisible by 4. But if it is not divisible by 2, it will definitely be not divisible by 4. So I don't need to check all values. I just need to check all the prime numbers that have come before it. So for 31, I would check 2, 3, 5, then 7, then 11 and 13 and all other prime numbers. So that way I will be checking whether a number is divisible by all the prime numbers that came before it. So I'll need a for loop for it. For I in prime. This is the vector that I am giving because I want to check all the prime numbers. I want to check whether the number is divisible by all the prime numbers or not. Say if n modulus I, whatever value I is, double equal to 0. If it is divisible, then do something. Do what? So I will have something called as an indicator. We'll say I is my indicator. At the beginning it is true. So I'm assuming that every number that I'm checking at the beginning is a prime number. And if it is divisible by any number in this prime number vector, then this I indicator, I will make it as false. I'll say I is equals to false. So if it is divisible by any number, then indicator becomes false. And if that happens, I don't want to run this loop anymore. That is, which is checking this, whether it is a prime number or not, whether it is divisible by a prime number or not. I know it is not a prime number. So I will use break. Break is a command that breaks the loop that is the nearest. So here I have two loops. I have a while loop, I have a for loop. But this break is nearest to this for loop. So it will break this for loop. So because if I find that it is divisible by 2, I don't need to check whether it is divisible by 3 or 5 or 7. So that is why I am using break, so that it breaks this for loop. But this while loop will still run. Now I have checked that if a number is divisible by any prime number, then my indicator becomes false. But what if n is not divisible by any number in this prime? Then I need to store it as a prime number in here. So that should be done after this for loop ends. So after this for loop, I'll write if in bracket, indicator is still true. So double equal to, you can just write capital T or you can just write the TRUE. Make sure that it is capital. So if indicator is double equal to true, that means I'm comparing. Then I need to store this number in prime. So prime is equals to a combination of the old prime, comma, n. And of course, I need to increase the value of n. That will be at the end of the while loop. So I'll say n is equals to n plus 1. That way each time, first it will check 3, then it will check 4, then it will check 5 and so on. Now when I run this, I'll just run prime. These are the first 25 prime numbers. You can see 2, 3, 5, 7, 11, 13, 17, 19 and so on. These are all prime numbers. So here we used while loop because we did not know how many numbers we will have to check to get these 25 prime numbers. Then we used for loop because we knew that we need to check each of these prime that are divisible, the number is whether divisible by each of these prime numbers or not. And I use this indicator as a switch. So it will be true at the beginning, and if the number is divisible by any of the previous primes, then the indicator becomes false. And at the end, I'm just checking whether the indicator is true or not. If the indicator still remains true, that means I have a prime number that I need to store in this prime. Then I increase this value of n so that I can check the next number. So I hope you understand the use of loops while as well as for. Most of the times in statistics, we use for loop just because it is easier to use than a while loop. That does not mean that the while loops are not important. So we should know the use of both while as well as for loop. That's it for this video. In the next one, we are going to see how we create data frames and how we use them. Do like, share and subscribe, and I'll see you in the next one.